Hi, let's do some calculus. I would like to work with you right now to find an equation for a tangent line to a function. This is a direct follow-on to my video in which I did a similar process using the definition of the derivative. I'm thinking about doing this problem in the context of Chapter 3, or that is to say differentiation. In case chapter numbers change for some reason. So I've got a function right here which defines a curve, and we'd like to find the equation for the tangent line at some specific point. So our mission is to write an equation for a line. Now, my favorite way to write equations for lines is to have two things about the line. I would like to have the slope of the line, and I would like to have a point on the line. If I have those two things, then I can use point slope form or y equals mx plus b. They're different pathways to get there to write down the equation for the line. So the point should be pretty easy, I think. The x coordinate is just going to be 4 because that's the point we're interested in right now. And the y coordinate is going to be given by evaluating the function at this point 4. And if I do that, I'm going to get, let's see here, let's plug in, instead of x up here, I'm going to have 4, so I'm going to have 8 from that term. So I'm going to have 2 times 4 plus 4 times 4 to the 3 halves, which is the same thing as 4 to the 1/2 cubed. 4 to the 1/2 is the square root of 4. So that part on the inside there is just 2. And then I have 2 cubed. Let's see here. 2, 2, 4, 8. So that's 8. So 8. 8 plus 32 is 40. Alrighty, so I got my point. Now we need a slope. Now we need a slope. Slope of the tangent line, instantaneous rate of change, the derivative, all the same thing, just thinking about them in different ways. So to get this slope, we're going to want the slope at 4. I'm first going to produce the derivative of f prime, and then we'll evaluate it at a point 4. I've already written little brackets above the two summands in my function here because I'm going to use the sum rule, S-U-M. I'm going to use the sum rule to do the derivatives for each of these two pieces separately. So I'm going to need to compute the derivative of 2x. And so I'm going to write that as dx of 2x plus dx of 4x to the 3 halves. So the sum rule tells me that I can do that I can split this up into this Lego and this Lego. I can peel those pieces of the function apart and just consider them separately, which is really nice. All right, now I'm going to use another rule, which is called the constant product rule, and I'm going to bring that 2 out front and that 4 out front. So that means that all I have to do is consider the derivative of x. I'm going to go ahead and write down one more line here. So that's going to be 2 times dx of x plus 4 dx of x to the 3 halves. And that's super nice because I just have power functions at this point. I just have x and x to the 3 halves. So I can just apply the power rule to these functions. So let's do it to x first. So this is going to be 2 times 1 times x to the 0, because there's a hidden 1. The power here is 1. Plus 4 times, let's see, 3 halves is going to come party down front. 3 halves times x to the 3 halves minus 1 is 1/2. And now we simplify. So I've got a 1 here. I might as well not multiply by that 1. Let's see here. X to the 0. X to the 0. Oh, that's just 1. So I'm just going to make that go away. So I've just got this 2. Cool. So now I've got 4 1/2 here. And they're going to turn into a 2 times 3 is 6. So this number right here is 6. And then I'm going to leave that x to the 1/2 there. This is the square root. The spacing is now a bit atrocious, but I think that's okay. So the last thing I'm going to do, I want to get the slope. This thing, if I evaluate at an arbitrary point, gives me the slope there. I want the slope at 4 because I'm considering point of tangent g is 4, 40. So now I finally need f prime at 4. I just plug in 4 for this expression right here. So I pick up a 4 right here, so I have the square root of 2. So it's going to be 2 plus 6 times 2 is 14. Alrighty, so I've got the slope and I've got my point. So as a last matter, all I have to do is write down the equation for the tangent line, and in the interest of not erasing, I'm going to go ahead and just do it over here. So I'm going to write y minus y naught equals m times x minus x naught. I like putting parens right there because it just really helps highlight the grouping of those. And then I'm immediately going to drop them because I'm going to go y minus 40 equals 14 times x minus 4. I'm going to simplify. So we're going to get y equals 14x. Let's see here. So 14 times 4 is the same as 28 times 2 is 56 plus 40. So that's going to give me 14x minus 16. And I have my equation for the tangent line. Yay. So again, summary of steps. I just needed to get the required information I needed, slope and a point. The slope was given by taking the derivative and evaluating that derivative and my x value. And the point was obtained by taking the x value and substituting that into the function itself. Put those together through our friend point slope formula, and we get the equation for the tangent line at the point. Thanks for watching, and I hope you have a lovely day.